Taylor series or Taylor's theorem. Now, போன கிளாஸ்ல என்ன பார்த்தோம்? Cauchy's integral theorem and Cauchy's integral formula. So here f of z is an analytic function. So this function can be expressed in the form of an infinite series. Like f of z is analytic inside a circle C with center at A and radius r. Then at each point z inside C, then f of z can be expressed as like this: f of a plus f dash of a by 1 factorial into z minus a plus f double dash of a by 2 factorial into z minus a the whole square plus etc. So this is called one Taylor's series. Suppose near the point, suppose a equal to 0. Suppose a equal to 0, or so f of z equal f of 0 plus z by 1 factorial into f dash of 0 plus z squared by 2 factorial f double dash of 0 plus z cubed by 3 factorial f triple dash of 0 plus etc. to infinity. So this series is called one Maclaurin series. இதெல்லாம் plus 2 ல படிச்சிருக்கோம். The near point a equal to 0 na, we may get this result. So this result is called what? Maclaurin series. Next Laurent series or Laurent theorem. Suppose if C1 and C2 are two concentric circles with center at A and radii R1 and R2, the R1 is greater than R2, and if f of z is analytic on C1 and C2 and throughout the annular region R between them, then at each point z in R, f of z equal sigma n varies from 0 to infinity a n z minus a whole to the power n plus sigma n varies from 1 to infinity b n z minus a whole to the power minus n. For f of z function complex valued function, so இந்த மாதிரி infinite series வந்து நம்ம expand பண்ண முடிஞ்சது அப்படின்னா that series is called what? Laurent series. இப்போ an அப்படி அண்ணினா 1 by 2 pi integral over c1 f of omega by omega minus a into d whole to the power n plus 1 d omega, n varies from 0 1 to etc. So put n equal to 0, we make it a naught. So this can witness part a naught z minus a whole to the power 0 plus a1 z minus a whole to the power 1 plus a2 z minus a whole power 2, like that. So you may get a naught, a1, a2 are the constants. You can apply this formula, you may get the values of a naught, a1, a2 etc. Right? Similarly, bn equal 1 by 2 pi integral over c f of omega by omega minus a whole to minus n plus 1 into d omega, where n varies from 1 to infinity. You may get b1, b2, b3. Right? So whenever there is no constant term in the negative powers of the coefficients, there is no coefficients of the negative powers of z minus a, then this Laurent series converted to what? Taylor series. So the Laurent series la negative powers, the bn oda value வந்து 0 னு ஆயிடுச்சு அப்படின்னா இப்போ இந்த series என்ன ஆயிரும்? It's nothing but Taylor series. Clear? So for example, so expand f of z equal to e power 2z in Taylor series about z equal to i. நமக்கு என்ன ஃபார்முலா நமக்கு தெரியும்? Taylor series about at z equal to a is nothing but what? f of z equal f of a plus f dash of a by 1 factorial into z minus a plus f double dash of a by 2 factorial into z minus a the whole square plus f triple dash of a by 3 factorial into z minus a the whole cube plus etc. to infinity. Is it right? So what is f of z here? So f of z equal to e power 2z. You differentiate it. So f dash of z equal to 2 e power 2z, and f double dash of z equal to 4 e power 2z, then f triple dash of z equal to, so 8 e power 2z. Clear? So e power 2z differentiate panna 2 into e power 2z, like that. So then f of what is a here? A equal to 2i. So this is a Taylor series about z equal to a. Right? So here z equal to 2i. So f of 2i equal to e power 2 into 2i which is equal to e power 4i. Then f dash of 2i, 2 into e power 4i, f double dash of 2i, 4 into e power 4i, f triple dash of 2i equal to 8 into e power 4i, right? You substitute in this formula, so e power 2 is z equal to f of a, that is e power 4i, plus f dash of a, that is 2 into e power 4i by 1 factorial into z minus 2i, plus 4 into e power 4i by 2 factorial into z minus 2i the whole square, plus 8 into e power 4i by 3 factorial z minus 2i the whole cube, plus etc. to infinity. So which is nothing but what? So you can take it as e power 4i outside, that is a common one. You can take it as e power 4i outside. So these are required Taylor series of the function f of z equal to e power 2z about the point z equal to 2i. Next example பார்த்தீங்கன்னா expand f of z equal to cos z in Taylor series about z equal to minus pi by 2. So this is the formula of f of z is Taylor series about z equal to a, f of z equal to f of a plus f dash of a by 1 factorial plus etc. Right? So here f of z equal to cos z in f dash of z. So differentiation of cos z minus sin z, f double dash of z minus cos z, f triple dash of z plus sin z. Is it right? I'll write up to 3 non-zero terms. Okay. So f of minus pi by 2. So a is minus pi by 2 here. So cos minus pi by 2, cos 90 0, right? So f dash of minus pi by 2, so minus sine of minus pi by 2, so is equal to plus 1, f double dash of minus pi by 2 equal to minus cos minus pi by 2, which is equal to 0, and f triple dash of minus pi by 2 equal to sine minus pi by 2, can take minus outside, so minus 1. We substitute in this, so cos z equal to f this is 0 plus f dash of this 1 by 1 factorial into z minus, so z plus pi by 2, and plus f double dash is 0 and plus f triple dash is minus 1 by 3 factorial, so z plus pi by 2 whole to the power 3 plus etc. to infinity. So these are Taylor series of cos z about the point z equal to minus pi by 2. Clear? Right. In the problem, find the Laurent series of f of z equal to z square minus 1 by z square plus 5z plus 6 valid in the region. First region modulus of z is less than 2. The second region 2 less than modulus of z less than 3. And third region modulus of z is greater than 3. First என்ன பண்றேன்னா the given function partial fraction பண்ணிக்கேன். So f of z equal z square minus 1 by z square plus 5z plus 6, which is equal to z square minus 1. You factor பண்ண என்ன வரும்? z plus 2 into z plus 3, right? இது வந்து partial fraction பண்றது numerator denominator same powerல இருக்கு. என்ன வரும்? So 1 plus a by z plus 2 plus b by z plus 3, right? You take LCM. So z square minus 1 equal to z plus 2 into z plus 3, a into z plus 3 plus b into z plus 2. So put z equal to minus 2, you get 4 minus 1, 3. This is 0 and this is 0. So a into 1. So a equal to 3. Right? Then put z equal to minus 3. So 9 minus 1 is 8. This is 0 and this is 0. So b into minus 1, so b equal minus 8, right? F of z equal 1 plus a on 3, yeah. So 3 by z plus 2. What is b? Minus 8. So minus 8 by z plus 3. So now you can apply this formula. You know this formula, 1 plus x to the power minus 1. You can expand this. So 1 minus x plus x squared plus x cubed minus etc. up to infinity, where modulus of x is less than 1. So there is a formula for the expansion of this. Suppose 1 minus x to the power minus 1. So 1 plus x square plus x cube. So here minus 1 minus x plus x square minus x cube. So all are positive. Here also modulus of x is less than 1. This result is true, right? So similarly, so we can take the first region. So modulus of z is less than 2. So this is nothing but 1. So modulus of z by 2 is less than 1, right? So in this f of z, I can take it as 1 plus 3 by, I can take 2 outside, 1 plus z by 2, is it right? Then here I can take 3 outside, 1 plus z by 3. So z by 2 is less than 1, obviously z by 3 is also less than 1, right? So 1 plus 3 by 2, 1 plus z by 2 whole to the power minus 1, minus 8 by 3, 1 plus z by 3 whole to the power minus 1. So we can expand this. So 1 plus 3 by 2 into, you can apply this formula. So 1 plus, instead of x, here is z by 2, okay? We apply this formula, I will get 1 minus z by 2 plus z by 2 the whole square minus z by 2 the whole cube plus etc. to infinity minus 8 by 3 into, and apply the same formula. So 1 minus z by 3 plus z by 3 the whole square minus z by 3 the whole cube plus etc. to infinity. This is nothing but what? The Laurent series about the region modulus of z is less than 2. Clear? So second region enna kuduthirukanga, 2 less than modulus of z less than 3. Okay, you can split this. So 2 less than modulus of z and modulus of z is less than 3. Okay, so it is nothing but 1. 2 by z is less than 1 and z by 3 is less than 1. Okay, and we will get 2 by z and z by 3 in this f of z. So f of z equal 1 plus 2 by z. So here you can take 3 z outside. So 3 by z into 1 plus 2 by z plus here you can take 3 outside. So 3 into 1 plus z by 3. You may get the expression 2 by z is less than 1 and z by 3 is less than 1. So in this expression you can get this result, right? So 1 plus 3 by z into 1 plus 2 by z whole to the power minus 1 minus 8 by 3 into 1 plus z by 3 whole to the power minus 1. So 1 plus 3 by z into, expand this, 1 minus 2 by z plus 2 by z the whole square minus 2 by z the whole cube plus etc. to infinity. Then minus 8 by 3 into 1 minus z by 3 plus z by 3 the whole square minus z by 3 the whole cube plus etc. to infinity. So this is the Laurent series of this function about this region, right? Third one, modulus of z is greater than 3, which is nothing but 1. So modulus of z by 3 is greater than 1, which is nothing but modulus of 3 by z is 1, less than 1, right? So therefore f of z equal 1 plus 3 by z less than 1, so 2 by z is also less than 1. So you can take z outside. So 1 plus 2 by z minus 8 by z into 1 plus 3 by z, right? So it is equal to 1 plus 3 by z into 1 plus 2 by z whole to the power minus 1 minus 8 by z into 1 plus 3 by z whole to the power minus 1. So 1 plus 3 by z, can expand it, so 1 minus 2 by z plus 2 by z the whole square minus 2 by z the whole cube plus etc. to infinity minus 8 by z into, you expand it, so 1 minus 3 by z plus 3 by z the whole square minus 3 by z the whole cube plus etc. to infinity. So this is a Laurent series of this function about this region. Modulus of z is greater than 3. Clear? Next problem. Find the Laurent series of f of z equal to 1 by z into 1 minus z valid in the region 1 less than modulus of z plus 1 less than 2. So போன படத்துல z மட்டும் இருந்துச்சு, ஸோ இங்கே வந்து எனக்கு z plus 1 இருக்கு. ஓகே, இப்போ என்ன பண்ணினா support z plus 1 equal to u. What will be the problem now? So f of u equal to 1 by, so z எப்படி எழுதலாம்? u minus 1 இல்லையா, z equal to u minus 1. So u minus 1 into 1 minus z is u minus 1, right? So it is equal to 1 by u minus 1 into, what is it, 2 minus u, yeah. Okay, இது partial fraction பண்ண வரும் a by u minus 1 plus b by 2 minus u பண்ண வரும் 1 equal to a into u minus 1 plus b into u minus 2 or 2 minus u. So put u equal to 1, you may get 1 equal to, this is 0, you may get b into minus 1, sorry, 2 minus 1 is 1, so b equal to 1 and u equal to 2, you may get 1 equal to a into 2 minus 1 is 1, so a equal to 1. So therefore this function is replaced as what? f of z f of u equal to a 1 by u minus 1, so b is also 1, so 1 by 2 minus u. What will be the region now? 1 less than modulus of u less than 2, right? So this is equal to 1. F of u equal to 1 by u minus 1, can take minus sign outside, 1 by u minus 2, right? So in 1 less than modulus of u less than 2, so which is nothing but just like the previous problem now. So 1 less than modulus of u and modulus of u is less than 2. This is nothing but 1 by u is less than 1 and modulus of u by 2 is less than 1. So therefore f of u equal to 1 by u. You can take u outside in this. So 1 minus 1 by u minus, here you can take 2 outside. 1 by, take minus 2 outside. 1 minus u by 2. Right? So 1 by u into 1 minus 1 by u whole to the power minus 1. So minus minus plus 1 by 2. 1 minus u by 2 whole to the power minus 1. So 1 by u, so 1 plus 1 by u plus 1 by u the whole square plus etc. to infinity. So plus 1 by 2 into, we expand this, 1 plus u by 2 plus u by 2 the whole square plus etc. to infinity. Now you replace u by z plus 1. So therefore f of z equal to, u is z plus 1, so 1 by z plus 1 into 1 plus 1 by z plus 1 plus 1 by z plus 1 the whole square plus etc. to infinity, then plus 1 by 2 into, so 1 plus z plus 1 by 2 plus z plus 1 by 2 the whole square plus etc. to infinity. So this is the right answer for this problem, right?